Welcome to our Bridging the Gap webinar from Greener Power Solutions. My name's Andy Parker and I'll be your host today. I'd like to give a special welcome to our power partners and the members of our Easily Emission Free programme who are also joining us today. We're really pleased to have you with us. Today, we're going to look at the grid, what it is, how it works, and why there's a need to bridge the gap. We'll cover how flexible power solutions like Greener's batteries can keep projects running. Now joining me today is Dan Pratt, our UK manager.
Hello there.
And Robert Scheick, who is one of our battery systems specialists. Now, this session is for anyone working in construction, events, energy or infrastructure. And our goal is to give a clear picture of how greener power solutions can bridge the gap where the grid isn't enough. But before we dive in, I just want to quickly run through how today's agenda and how this session will work. So over the next 30 minutes or so, we're going to cover three main topics. Firstly, a quick overview of how our batteries work. Then we'll discuss the grid, how it works, what it delivers, and what the limitations are. After, we'll share some real-world case studies where we'll finish with a Q&A. As always, and those guys who are familiar with our webinars, we encourage your questions. So please use the chat function and one of our experts will be on hand to answer as we go. Now, we're going to save some of the better questions for a live Q&A nearer the end of this webinar. So let's start with a quick introduction as to who we are. Greener Power Solutions was founded in the Netherlands with a clear mission, and that was to speed up the transition to a cleaner, more flexible energy future. Now, one of the main ways we do this is by supplying energy where the grid can't supply it. And it all started with a challenge. How can we reduce the reliance on diesel generators for temporary power? And the answer lay in mobile battery technology. And in 2018, Greener was born. Now, since then, we've grown from a small Dutch startup into a European provider where today we have a fleet of more than 200 battery units. We supply clean energy to the construction, events, grid, and EV charging sectors. And our operations now cover the UK, Netherlands, and beyond. Now, what makes us different is not just the battery hardware. It's also our in-house energy management system, which optimizes energy use in real time. And this means lower emissions, better performance, and smarter integration with renewables. Now, across Europe, the energy landscape is changing and quickly, and this rapid change comes with challenges. Now, grid congestion. Many of your projects face delays due to limited capacity, long wait for connection upgrades, and as you know, this is our main topic for today. Diesel dependence. Diesel generators are still widely used despite pressure to decarbonise, and Greener is trying to change the status quo of temporary power. Rising energy costs. Prices are volatile. Businesses need stable and affordable alternatives with flexible financial models. And we're all under sustainability pressures. Governments, clients, communities all expect greener practices, and they expect them quickly. Again, with your help, Greener can deliver that. These challenges are shared across borders, and that's where bridging the gap becomes so important. So let's look more closely at the challenges tied to the grid. The gaps we will focus on today is, firstly, no power at all. Now, you've all probably got projects where there is no site power whatsoever, and completely off-grid. Construction sites, rural events, all power must be supplied from scratch. There are projects where there's not quite enough power. You've got a small connection, but it's too small to cover peak demand. And this often leads to project delays, costly upgrades, again, or a reliance on diesel. Now, waiting for upgrades, infrastructure projects often sit in limbo while they wait for new capacity, substations, or simply connections. And this is where Greener's temporary and flexible battery solution make a real difference. They bridge the gap until the grid can deliver what's needed. Our mobile battery solutions are already bridging the gap across the UK and Europe. Across construction sites, we're helping projects run off grid. by cutting diesel use by up to 80% in some cases, and it keeps power reliable. Across the event sector, we deliver clean, quiet energy to festivals and outdoor events. This improves the experience without compromising the performance. And grid support. Our batteries allow projects to begin even when grid access is delayed, and they act as a smart bridge until the capacity becomes available. Now, EV charging, we've done many projects in this particular sector, and we support the rollout of fast charging hubs in places where the grid capacity has not yet reached. The journey to net zero requires innovation, and battery technology is moving fast with greater capacity, longer lifespans, and smarter control systems. At Greener Power Solutions, we're proud to be at the forefront of this shift. We offer clean and flexible solutions that are scalable and reliable. With our support, businesses can move quickly towards emission-free operations without waiting for the grid to catch up. Now, I'll hand you over to Robin, our systems specialist, and he'll walk you through the essentials of our battery technology and our EMS. Robin, over to you.
So I'm going to talk to you a little bit about the solution that we have in our fleet, which most of you probably already know. But it's a 10-foot container. Oh, a standard 10-foot container. The standard 10-foot ISO container, the same as we find in shipping around the world. Within this 10-foot container, we have three main components, really. We have our main common bus with a input and output section with a small extra output section on the container. Then we have parallel onto that bus a inverter and a storage capacity in lithium-ion batteries. Having said that we can see one input section and two output sections. This is because we can stack the entirety of the inverter on top of the entirety of the input, which are both rated at 400 amps or 250 kilowatts. So that means that if you have the battery standing there with no extra support of energy on the input available, you have 400 amps or 250 kilowatts available on the output, plus whatever you add from the input. So that's a little bit about the hardware in the battery. A very important note to say is that on the common bus, there is this three-way transformer giving a galvanic separation between the main components being the inverter, input and output on this battery, which solves a lot of earth leakage faults and other interesting things. All of this is controlled by our EMS, energy management system. So you can imagine that all the components which you have been, which I was just telling you about, are controlled within the machine itself, which is built by a OEM, original equipment manufacturer, and then we give all of that a set of set points or instructions what we want it to do. And then from the EMS, we have the Greener Watch. So what's the difference between the Greener Eye and the Greener Watch? The Greener Eye is the actual little box.
The computer itself.
The computer itself, which is this thing, where the Greener Watch, which is a bit of software, watches all the other bits and pieces which are in the energy grid. So the Greener Watch then does some decisions about which energy sources are operated at which time, and then projects all the data it's gathered back to the cloud into a database where the Greener projects
and
software
controlling other assets that might be connected to a separate or the same microgrid or grid.
Yeah, absolutely. And we can remotely start stop generators, and we can remotely curtail solar or any kind of other interesting power source which is there. I have not seen a guy on a bike yet. And then all this data has been sent to our database in the cloud, which we then can make viewable in Greener projects. And these will give you some will give you all the information of your project in a historical fashion in graphs. And you can also download energy reports, which we'll touch upon near to the end of the last case, which we were talking about in a minute.
So the visibility of that data is really important for people to understand what's going on with their energy assets on site, or how the power is being used, or how they're utilising grid connections.
And how the difference
The data is key to that. Yeah.
Absolutely, and how the upfront expectation may or may not differ in a positive or negative sense towards their real life project after it's run, and that you can take some very interesting learnings from that for the next one, and maybe scale up or down accordingly.
So information is power. In that
Information is key.
Yeah.
We have a Dutch saying, meten is weten. If you measure, you know.
Very good.
So if we've got all of this information, then we can do all sorts of things with the hardware. So there's a couple of interesting words here, like 24/7 monitoring, on-site storage energy, which we will talk about in the one of the cases, zero emission, where we are able to exclude all, by load shifting, exclude all kind of emissions on site and all the other things which are here. So this is a bit about the hardware that we have in a single container. And we'll talk a little bit about the grid, and it's over to Dan to explain a bit about that.
Thanks, Robin. So we thought this webinar was focused on grid-related projects, so where grid power should be being used, but there's shortages, etc. So we thought it would be useful to give a bit of an overview on the UK grid, how it works. So on your screens now, you should see the slide, which is basically demonstrating how energy is generated in alternating current, and then through step-up transformers sent onto the transmission networks, which are running at very, very high voltages. Now, we run that very high voltage in between transmission points at such high voltage because we need that electrical pressure to get enough energy in between the various power assets that are generating energy, and equally the power consuming equipment that is plugged into the grid. Yeah. So that's the transmission network, and then downstream from that, there's the distribution system operators or distribution networks. They're running at sort of medium voltage, so 11 kV or 33 kV. And the reason we step down there is it's just that it's kind of a cascade of high voltage transmission down to medium voltage, and then ultimately to low voltage, which typically would be 400 volts three phase or 230 volts single phase, because that level of voltage is what we need to actually power physical bits of equipment.
Yeah, and the reason that we used a higher voltage in transmission systems is because the current is subject to resistance. So you want to reduce the current, and in physics says that power is the voltage multiplied by the current. If you up the voltage, the current goes down, and you have less loss over the line.
Absolutely. So the other thing we did want to just discuss briefly, because it is connected to how we use the battery systems on grid, which is all based on frequency control. So the national grid in the UK itself is managed by the ESO, or National Grid ESO, and the job of that central control system is to maintain 50 hertz on the grid at all times. So I think the frequency tolerance on the grid
0.2.
0.2 hertz either
up
side.
and down.
So yeah, and that's the job of the ESO. But we also use this use the frequency in battery systems to control microgrids and power flow across a network.
Yeah, well, it's the same in the grid as in a microgrid, except for the scale.
Yeah.
If there's too much energy, the frequency will be high, and if there's not enough energy, the frequency will be low. So you have to adjust accordingly.
So we wanted to move on towards private wire networks. So you can see here that this would be a typical private wire network. So there would be a large supply coming in to a private wire network. Now this could be a conference centre, it could be a sports stadium, it could be a port or an airport or a hospital. Generally, all these things run private wire medium voltage networks.
Large long-term construction sites.
Also temporary constructions, they do run medium voltage grids.
Temporary as in years.
Yes, yeah, absolutely. So here you can see that we've got obviously the grid coming in, and then there's factories, manufacturing plants, EV charging. However, private wire networks are also starting to see a lot more on-site generation through like privately owned solar installations or privately owned wind turbines. Mm-hmm. They're all connected to the private wire network and are effectively importing or exporting power to the grid. Exporting power in the case of the generating assets. However, we wanted to look at battery storage on the grid and what that can mean for you. Mm-hmm. So really, it's about how battery storage on a private wire network can really help manage energy demand and help smooth all of that out through allowing a buffer in the middle of that private wire network.
Exactly. You can imagine if you have a long week, a weekend of no work and solar, then it's no point in exporting the energy back to the grid if you can use it at night to keep the lights on.
So keep it yourself in batteries, and then you can use it when you're ready.
Yeah, but we'll dive into it in the cases.
So yes, the first case, I'll hand back across to Robin, which is this case here.
Yeah, grid boosting for seasonal or temporary need. We wrote down seasonal need here because we're going to talk a little bit about a transport hub or packaging sorting hub, which obviously has a little bit of a peak usage during the end of November, December, and then a little bit in January when all the stuff goes back again. And this place had a free MVA connection, and then that was more than enough for the most of the year, except for this temporary moment, which is a seasonal moment at the times I just noted. And how they and then you can imagine that because the pressure goes up, they rent in some extra equipment, and that was a little bit too much for their connection right there. So if you look at what they did for the last couple of years before they talked to us, they put in 4 generators, 500 kVA. Stage 5, which had to run at between 50 and 80%.
So the DSO limit on that connection to the distribution center was 3 MVA or 3,000 kVA, but they needed an additional
1 to 2
MVA of power. Yeah.
So you can imagine if these are running, you've only got blocks of energy that you can stick back. You can use to push the.
So when the demand goes over the 3 MVA mark, the generators will
kick
start,
in.
But then they're going to run.
Yeah, for a certain amount of time, and at a certain power, which is not as flexible as could have been used. That's
which also means
to us
any over generation. So if the site load does drop below the 3 MVA limit, then the generators are still online. Any additional energy that's being generated by those diesel engines is going to make its way straight back across to the grid, and you're just throwing that generation away.
Exactly, and you can imagine that a kilowatt hour from the DSO is significantly cheaper than a kilowatt hour coming out of a generator.
Yep.
Regardless of just as a cost. So they came to us with, can you solve these 2 problems at the same time? So of course we said yes, and we decided to stick in a system that looks like this. We have 5 batteries producing 1.125 megawatts of energy, storing just about 2 megawatt hours of energy. What's the beauty of this system? As you can see, there is no diesel here at all, because what happens is if the plant has a high demand period of time per day, it also has a low demand period of the day. But DSO is good for its connected value 24/7. So you can use the downtime to charge the batteries, discharge the batteries during the high demand period of time, and use the very cheap energy coming from the DSO in order to cover the entire peak. And in this manner, we were able to negate all of the diesel generators, have no fuel cost whatsoever.
So it was just about timing.
Absolutely. We call that load shifting.
Yeah.
Shifting the load demand from one place to the other place.
And batteries is what enable that to happen and work.
Exactly. You shift the energy back and forth. It's available at one point, and it's not enough on the other point. So as a result, we had a large peak shaving system in action. We had a cost and compliance benefits. There was also a restriction on the amount of emissions which were allowed to be emitted in this area. It was next to a forestry place. So, and then the cost reduction in diesel near about paid for the system itself, because you can like I said, the cost of a kilowatt hour out of a diesel generator is significantly more expensive than it is getting the same kilowatt hour out of a DSO or out of the grid, especially at large scale connections. Well, there you go. So that's a little bit about this case. It's over to you for another case which is even larger.
So yeah, I mean, ultimately, this case does end up with multiples of what Robin was just describing, but it's more to do with again a private HV network or a private wire network. So this specific challenge that we had was due to the network intake being at the limit, at capacity. But the site itself had a roadmap to increase electrification of the equipment that's being used on the site by over 100%. So they needed to double their intake. Now that comes from a very large cost to double these large high voltage or medium voltage intakes from the DSO. So they came and spoke to us about if there was something we could do to help. So we came up with a three-step approach. So first, what we needed to do was identify any of the dynamic loads that were on the site. We needed to measure these and graph the load profiles. So we took a measurement device and installed it at the main intake point. Had there already been a measurement device at that intake point, we could have read that out and got that displayed in our online dashboard in Greener Projects.
Yeah, and this is always the installation of or reading out the installation of a measurement device or reading out a already existing measurement is always project specific.
Yeah,
you can do lots of things. The measurement device that we have, which is over the left-hand shoulder of Andy.
Is an example of
what we can do.
Yes. So after we sort of did a site assessment and we installed some of the metering devices to understand what was going on the site, we then were able to assess the viability of battery systems and come up with a proposal that would work for us to install batteries at low voltage on the low voltage side of their transformers on site. And then finally, after this was all installed, we were able to measure and graph the main intake point again and see what impact the installation of the batteries storage devices has had on that. And you'll see as we work through this that it ended up working out quite nicely for the customer. So the site layout itself was a 33,000 volt line coming in to a step-down transformer that powered an 11,000 volt ring that then had 4 step-down transformers locally on the site. So as we discussed just a second ago, we fitted the metering or read out the existing meters. So the loads that were on this site were, there was some tower crane loads and there was some electric vehicle charging simulated by the icons we have here. And then there was a factory or an office type building, various different kinds of loads across the site. So through that, we were able to fit the meters and then get all of that data pushed into Greener Projects, which then produces the graphs, as you can see on your screen now. So the loads that we were looking for, as I said previously, are dynamic loads. So this was the EV charging load profile, and you can see that it's very, very, well, zero. Pretty much the load is zero when there's no cars or electric vehicles at the charging station.
Next to nothing.
Yeah, exactly. Powering a screen or a few LEDs, next to nothing.
A few computers. And as you can see here at the right bottom hand corner, I'll just draw your attention to it. You have a very large difference between min and maximum capacity, and then you have because this is a 24-hour window. The minimum is 1.8 kilowatts, and the maximum is 168, let's say 170 kilowatts. But on average, that's only 14 kilowatts. That's a 32 amp plug.
So we could have got enough energy from a very, very small grid connection in order to do this.
That's just a CE32 being used 24/7.
Absolutely. As you can see in the middle there, this is the section where the cars are charging during the daytime. They obviously come in, park up, whatever it might be.
Mm-hmm.
So the next area of the dynamic load that we'd already identified as being a prime target to look at and see if batteries would work would be the areas that the tower cranes were. So again, you can see from the load profile on the screen now that when the cranes aren't being used, the load is zero, or in this case, the minimum of 0.16. I suggest they actually turn them off. Mm-hmm. But again, high peaks, maximum of 127 kilowatts, and it's jumping around all day as the cranes are doing their operation. Yeah. But again, looking at the mean value there, it's suggesting that although very high peaks of 127 kilowatts, the mean value is only 5.
So that's 2 wall sockets. That's it.
We could have gathered enough energy from two
wall sockets
to
in your office.
Frame.
That's it. That's all it needed. And it is tower cranes are really interesting because obviously you only need, according to physics, you only need energy when you work against gravity, and all the other times you do not.
Yeah, yeah. So a load dropping down pushes
energy back in the battery.
Yeah. So the third area that we monitored was the offices or the distribution warehouse, like a heating load, anything like this. It's very constant. There was a slight difference again between the minimum and the maximum, creating a sort of average mean, but not really something that we could do a huge amount with battery storage because it's just a constant load. It's not not much we can do there.
Especially in comparison with the other ones, the business case here is a lot thinner than it is on the other ones.
Exactly. So that's where we focused our efforts. So going back here, the 4 areas that we monitored, 2 areas of cranes. Yes, let's look at batteries. The EV charging again. Yes, batteries. The high static base loads. There was something we could have done, but not enough to really have an impact. So we can literally look at these and connect batteries in parallel with the low voltage supply and set these batteries to do the peak shaving. And what this means is the peak shaving, we can set the batteries to deliver energy across the meter at a set time and then recharge from a low time. Exactly the same as Robin was just discussing in our first case. But what that means for the main intake position is all of those spikes that would have been appearing on top of the base load have now been suppressed by the battery storage systems that were installed on site.
Yeah. So for instance, this line here, where you have 2 peaks just about on top of each other,
They
would have
balance
been
out.
absolutely nothing.
Yep. So to finalise this case and on the results, we were able to solve the client's power issue, so their power shortage, by installing metering to understand what was going on in the site, and then eventually through that data-driven approach, fit the batteries to do the peak shaving, which really alleviates the requirement for them to have a grid upgrade because they've just managed the energy that they've got on site. And this could also work. The data's really the key, because they could look at this and say, well, if I installed some solar on site, then that again has an impact. But you do need batteries to help manage that. It's the central buffer of that whole network.
Yeah. So for instance, it's useful to put solar on the offices and then
Absolutely.
take that little bit of bulge in the middle of the day, press that away by the solar, for instance, and then you get a flat line. Well, nearly.
Absolutely. So that was that case.
There you go.
Moving on to our final case, I'll hand back to Robin.
Yeah, so this is about food, because we went cooking in the forest. That's why I get to do this. So we got a question from a festival organizer asking for a 1 megawatt peak with a 2 megawatt hour usage in a 24-hour time period. This is, and if we could have a solution for that in the middle of the forest where there is absolutely nothing. Well, not absolutely nothing. There was a 50 amp grid connection available. So if we look at it from an overview point of view, this is the on the slide now. You can see there's the load, the predicted load. So this is what they just added up together and see what, and then came to a maximum, and an estimate of 2 megawatt hours a day.
So 1 megawatt peak demand, if everything was switched on,
Yes.
within a diversity factor applied, I assume, you'd hope.
Yeah, probably not.
But either way, but the energy consumption suggesting 2 megawatt hour over
24-hour period. And then they also, but we also have a 63 amp connection laying around.
So most people would disregard that and go, yeah,
Yeah.
I need a megawatt. What good is a 30 kilowatt supply going to do for me?
Yeah, exactly. But that first 1 megawatt hour of energy comes directly from the DSO. In Holland, because that's where this festival was, at 20 cents the kilowatt hour, as opposed to €1.50 when it's coming from a generator. So that's a significant reduction in cost right there for the first 1 megawatt hour of energy coming in.
And that infrastructure is already there.
Yeah.
You don't have to bring generators, fuel tanks, service
It's a cable.
engineers, trucks.
It's a cable.
Yeah.
And then, so obviously we needed to make sure that we could get to the 1 megawatt from that 50 amp connection. We were not going to do that directly online, because the difference between the 1 megawatt and the 50 amps, or was it 33 kilowatts, 30 kilowatts?
63 amp C connection, yeah.
It's too big. So what we did is we built a little setup with 4 batteries in parallel using our microgrid technology, which is the same frequency driven system as the main national grid is, as Dan already talked about.
That microgrid, it's the 4 batteries that are now forming the grid.
Yep.
Although you can see it was integrated with a grid connection.
Yeah, so
This is where this is different to the cases we've previously discussed.
exactly. And the magic happens in between here. where we use our AC/DC/AC technology to make the frequency separation between the DSO, so that's whatever's happening in the grid, and our own microgrid, which is on this box. So we go through 0 hertz through DC, and then make it do whatever the frequency on the secondary side is in our microgrid. And then because we control the frequency there, we can use that frequency for the batteries to communicate to each other how full they are individually, and then balance their state of charge, and equally participate in the energy that needs to be delivered. And another nice thing, and this is also hot swappable on site under operation.
So the way that they're connected, because they're through their synchromatic contactors onto a common bus position, if this battery here were to have an issue, you can just disconnect that set of cables, remove it, replace it.
Yeah. Or if they did their calculations, so this was for 1 week, so you're not going to scale up and down. But if you're doing a longer term system,
the data
you can scale. You can hot scale up and down without having any influence on your process whatsoever. So you can, if you then go back to the seasonal thing, if you have got no connection or a very small connection, and you're going into the winter season where you have more heating, or if you're going into your high demand period of time, you can scale up more battery systems for that period of time with no interruption whatsoever to your power supply.
As
required. Absolutely. What we did need to add to this project, though, is a little bit more energy, and we could do a small generator or a small supply, and in this case it's going to be generators, because that's still the most effective way to transport energy over for a temporary time. And we decided the customer decided to put 300 kVAs in there in order to be fast charge, as opposed to having a generator constantly running. We will run these in fixed power at whatever the owner of the generator thinks is its most optimal.
So around
set it
70 to 85%.
Yeah. At our preference, yes. Absolutely, as high as possible.
But again, those generators are controlled by the greener EMS that is in the batteries.
And we have a nice graph to show you how that works. So in this slide, we see we see 2 lines. We see a purple line and we see a blue line. The blue line is the load, so you can very clearly see show days. And then you can also see the load in period of time and the load out period of time. Apparently, people are much more effective at taking away their stuff than putting it down.
Although this was an event, this would be apparent to anything that had very high demand or consumption during the day or the night, whichever way around it is, and then low off periods.
Yeah, absolutely.
So you could
regardless of the time scale itself.
Yeah.
So what you see here is also very clearly that there's 3 different heights of energy being added. We have the low energy, the low horizontal line being the grid connection, constantly adding energy. But as soon as the batteries are depleted, they fire first the first generator, and if then they're still depleting, it fires the other generators as well, as you can see here. So there's a 3-stage rocket charging the batteries quickest, very quick.
But keeping that grid connection, pushing as much.
Oh yeah, that's a horizontal line at cost continuity 1.
Yep.
Just doing kilowatts and nothing else. All right, and then we also have an overview of this energy usage during the entire project coming out of our Greener Projects software, in which you basically see you have a little bit of added information about generators starting and stopping, and you can see that what the state of charge is, and then the energy usage itself.
Very good.
So that's it. And then in this setup, we managed to save around about 2.3 thousand liters of diesel on just this project.
Just over 1 week.
Well, not even.
Not even a week. Yeah.
There you go.
Fantastic. Well, I'm sure you guys will agree, some really useful insights there. And that brings us to our Q&A session. We've got some great questions, so I just want to dive right into them if I can. So I suppose not in any particular order. We've got one question here from one of the guys watching this. This particular individual, his own experience in leading accounts in the UK, Europe, and North America. Many clients still default to cheapest KVA on hire, which is the natural default for most people. However, kind of working a hard shift to that conversation towards life cycle savings, emissions, and fuel optimization. But naturally, it's not all that easy, not always easy. So what strategies have we found the most effective in helping customers actually value those outcomes, rather than just weekly rates? So how can we benefit the client by showing kind of not only savings, but obviously the emissions saved, not actually requiring a massive grid connection to have huge outputs? So, you can give a bit of an overview, Dan, perhaps if you want to give a snapshot on that one.
So I think as we were looking at through some of the cases, really data is key. So understanding what you're doing with energy or what power requirements you have for any project or permanent installation might be, that's crucial. Without that, you really can't design anything properly.
Yeah, we've done on more than one occasion. Well, if you don't have more defined data, what we do, build it traditionally. We take one of our mobile meters, we'll measure what you're actually doing, and then decide on a strategy upon those real life measurements.
So a more consultative approach, basically.
Yeah. And very often, very more often than not, you will see that the estimated usage is significantly higher than the actual usage is. Yeah. For I neglected to mention, but in the project that I mentioned last, the peak load was not even 250 kilowatts, as opposed to the predicted load of a megawatt. So next year it'll be half the equipment.
So in order really to get anything like this designed in a sensible manner, is the data's needed.
Right,
it's the only way.
And that's obviously we can help with the metering and what have you.
Yeah, and I guess the final thing on that is that's what Greener Projects has been designed for. It's to understand needs, but then also for a live project, because all of the data from our battery systems is being sent up to the cloud, gives you real-time views and the ability to run energy reporting on the assets.
At a 1 second interval.
Yes.
So the resolution is per second.
Okay, brilliant. Cheers. Hopefully that's kind of give you an idea there with that one regarding an answer. Another question here. Does the EMS have the ability to talk or control other energy systems outside of the battery, i.e. disconnect buildings' EV chargers as load and energy dictate?
Short answer, yes.
Okay. Well, hopefully that's answered your question.
And then the manner of doing that is project dependent. You can imagine that solar, you don't want to switch on and off, but maybe you want to do plus or minus a bit when the batteries are full, keeping them at capacity while the sun is there. Or and generators, you want to switch on and off at its peak efficiency.
And specifically for EV charging, if you have lots of very high power superchargers, then yes, you might have a limitation on a connection point, or want to put only a specific amount of batteries in. Then yes, our EMS can control the EV chargers to suggest if there's a block of 10, if there's only 2 cars charging, allow full power. If we get to eight of the chargers being in use, we can limit the amount.
Balance it out, basically.
The batteries can control the car chargers in that way.
Good. Okay, another question. I'll answer this one actually. Will you ever expand to the African market regarding microgrid projects? Interestingly, we've just had an inquiry about 4 or 5 weeks ago for Somalia. Again, we're going to take each case on its own merit, but this is a UN-based project, so the short answer is we'll take a look at it and then obviously assess it on its own merit. One other question. What's the most interesting off-grid project that you've ever made? So, Dan, can I throw that one to you?
Interesting off-grid project. Yeah. That's thrown a curveball. I have to rack my brains. Have you got any suggestions?
Oh, that has to be the construction yard with a very big cement mill there.
Oh, the big concrete batching plant.
Batching plant where we went from 400-500.
We covered it in the first UK webinar that we did. I believe. Yeah.
We went from a massive amount of generators doing NAFL
two 1,200 kVA generators. Yeah,
To a
that was
single 200 or something like that.
Yeah.
Okay, cool. And fifth question, what's the smallest or lowest input supply that we can work with into the batteries? What's the smallest that you would recommend?
So if you're doing peak shaving on a grid,
Yep.
you need a connection of 50 amps rated, which we can then curtail back to 20. And you need the 50 for the inrush of the transformer in the battery.
Gotcha.
So it's a peak, and then it's fine again.
Okay. We've got another one that we can run through. We're trying to rattle through as many as we can. Do you have the same grid connection regulations in Holland as here in the UK, EE G99 regs? How do you meet these?
There are the similar regulations. There are some slight differences in that. But yes, we're working with the OEM to get full compliance for connection on those. And they have to run through a case-by-case basis with the DSO signing off.
Okay, and one final one. How do we manage the control of ensuring no export to grid when it's not allowed? Kind of follows on from that.
So there's a software restriction. We measure what we take from the input.
Yep.
And then you put a limit there,
Yep.
and it just keeps the limit. That's what it is.
Simple as that.
And if it needs to be G99 on the newer models that we're looking at, we're looking at also using the AC/DC/AC technology, which just allows a one-way flow of the energy. It's impossible, except for very interesting flame arcs, to to push it back in the air. Yeah, there's different problems at that point.
Good stuff. Well, thanks, gents. It's been really insightful. And thanks for all your questions. Please feel free to reach out to us via email with any additional questions that you've got. And that brings us to the end of today's session. So thanks again for joining us on our third webinar, Bridging the Gap. Special thank you once again to our power partners that have joined us today. And if you haven't already, please sign up for our next webinar, which is going into advanced setups, and that's on the 6th of November. In the meantime, we'd love for you to stay connected by signing up to our newsletter. So just scan the QR code that's on screen now. Get updates on upcoming webinars, industry news and insights from the Greener team. Again, thanks for spending your time with us, and we look forward to seeing you at the next one. Take care. Thank you.
Bye.